Hello, everyone, and welcome to Getting the Net Zero Energy Ready by 2030 Lessons from BC's Energy Step Code webinar. A few housekeeping items to mention before we get started with today's webinar. All attendees are on mute. If you have a question for me or today's webinar presenter, please send it through the questions section on your GoToWebinar dashboard, or you can use the Raise Your Hand feature to ask your question verbally. You can access the question chat box by clicking on the plus sign next to the question header on the dashboard. To access the Raise Your Hand feature, click on the hand icon that is also located on the left side of the GoToWebinar dashboard. We will then unmute your line and you will be able to ask your question. All questions regarding the presentation content will be held until the end of the presentation when we will open for Q&A. Without further delay, I would like to introduce our presenter, Zachary May. Zachary is the Director of Building Codes and Standards for the Province of British Columbia, with a Building and Safety Standards branch. He is a member of the National Standing Committee for Housing and Small Buildings, Part 9, with the National Research Council and participates in a wide range of initiatives driving innovation in the construction sector. He is the chair of the BC Energy Step Code Council, a multi-stakeholder advisory body that supports the development and implementation of the Energy Step Code. Without further delay, let's begin. Zachary?
Thanks very much, Anne. So hopefully everyone can see the screen. I've also got the webcam running if that's easier for some people during the presentation.
Yes, hello, Zachary. We can see you.
Excellent. Hi, everyone. And I should warn everyone, so thanks very much for having me and the introduction. And before we get started, I'll just warn everyone that I work in an open work plan office, and it's possible someone jumps in here not knowing I'm doing a presentation midway through. So apologies in advance if that happens, but that's meant to work in BC. So I'm going to make sure we leave at least 20 minutes for questions at the end of this. Today's presentation, for those of you not in British Columbia, apologies, this is primarily focused on what we've done in British Columbia, but as mentioned during Anne's introduction, I do a fair amount of work with the National Code Development System, and I think there's what we've done in British Columbia provides a lot of insight to the kinds of questions, the kinds of issues we're going to be seeing in the National Building Code in the coming years as we move towards the federal government's commitment of moving the building code nationally to net zero energy ready as a minimum standard by 2030. And in British Columbia, we've gotten a bit of a head start on that for a handful of reasons. So I'm going to walk through fundamentally what's driving the development of the STEP code in British Columbia and how that relates to similar policy drivers and commitments federally to move towards net zero energy ready. We're going to take a look at the steps and metrics, really how we're measuring energy efficiency in the Energy Step Code in British Columbia and what that means for buildings and how that's different from the way that we measure energy efficiency in the National Building Code today, at least. And then really drill down on one of the new elements, which is a real specific focus on the building envelope separate from mechanical systems inside the building. And again, what that's likely to mean for building design and for suppliers of components that go into the building envelope. So I would assume that'd be of strong interest to many of you on the webinar today, because there are some changes with the way we measure things in the Energy Step Code, and it raises some questions about how we might deal with that in the National Building Code going forward. And then I'll just highlight some local governments that are implementing the STEP code early that, again, I think has some national implications around how we might see a national net zero energy ready code roll out earlier than 2030, at least across the country, and take a bit of a dive into some of the costing analysis and research that we've done and pull out some interesting findings we have around what it means to build under the Energy Step Code framework, what that's revealed to us around the most cost effective, the most energy efficient buildings, and how builders are going to need to be making choices in British Columbia, at least going forward, and what that might mean for suppliers of different materials and assemblies for those buildings. So the Energy Step Code in British Columbia was really driven by a combination of forces, some provincial and then the rest federal halfway through. We changed the way that we regulate buildings generally in British Columbia in 2015 under the Building Act, but prior to that we didn't have a specific act dealing with construction of buildings. And this really pulled a lot of levers from local governments and other players in terms of deciding what technical standards are for buildings back to the province. Really said we need greater consistency on what the minimum expectations are for construction, and that should be coming from the province, primarily in the form of the building code. And so what that signaled to local governments, particularly on energy efficiency, where they were implementing their own policies or bylaws, was that by December 2017, so just behind us now, they would no longer, they being local governments, would no longer be able to enforce anything other than the BC Building Code unless they had specific permission from our office. And so in this case, with the Energy Step Code, what we were trying to do here was support the need for local governments to push the envelope on energy efficiency, which they do have a mandate to do in British Columbia, but do that in a more consistent way than we were seeing on the ground. And we'll walk through how we manage that balance of allowing flexibility, but creating a clear, consistent path that the province holds the pen on. The other big policy driver that is applicable across the country, separate from this regulatory change in BC, is the Pan-Canadian Framework on Clean Growth and Climate Change. This is the agreement between all jurisdictions except for the province of Saskatchewan, I believe, at this point, where there's a clear commitment from the federal government and the provinces and territories to move construction across Canada to net zero energy ready by 2030. Really important to note, this isn't a commitment to net zero, so this isn't offsetting anything with solar panels. It's also not net zero carbon. The commitment appears to maintain the National Building Code's fuel neutrality approach and material neutrality. We just tell people how to build buildings and how to use energy once it arrives at the site, but don't get involved in energy distribution policy. But the shift really is, and it's quite ambitious, that by 2030, we're going to be building net zero energy ready buildings as a minimum standard across the board. And while today we're going to be focusing on a plan for new buildings, that's what the Energy Step Code in BC relates to, and this 2030 commitment federally, it's worth also noting the federal government has also committed to, by 2022, coming up with a building code for existing buildings. So to identify a similar roadmap for existing buildings. That's arguably much more complex, so we're not likely to see that until at least 2022. And so this code development work nationally is underway to answer that question around what is net zero energy ready. We don't have a consistent definition in North America for that term. And then to start mapping out what does that mean in the Canadian context, in Canadian codes? What does that mean for all of the requirements we have in the code, and how are we going to get different jurisdictions towards this very ambitious long-term energy efficiency target? And so in British Columbia, the Energy Step Code is really our answer to that policy question, but that's a question now that's posed on the country, and we need to make a decision and have a discussion around how we get there. And I think what we've done in British Columbia at least provides some information, if not certainly not a perfect answer that could work across the country, but we have an idea of how we can approach this ambitious target. The Energy Step Code in BC primarily, as identified on the screen here, was really meant to identify, build off all the progress that industry has been making voluntarily, that local governments have been encouraging through policies and programs, and find a consistent standard for all the great green building programs out there that all define energy efficiency differently. Some have a much wider lens than others. Passive House looks just at the building itself and its energy efficiency. We look at a program like LEED, and in some cases Built Green, that looks at broader sustainability concepts, materials, how we're treating the site, things like that. And really try and identify in the building code, where we're just dealing with really the process between the four walls of the building, how can we create some technical standards that lead to improved energy efficiency that don't point explicitly to any of these third-party programs, but allow builders to use them voluntarily, as they were always meant to be created. And ultimately, that's what we did with the Energy Step Code, was try and build off all of this progress, particularly any programs related to the Natural Resources Canada's EnerGuide rating system, and come up with a single consistent roadmap for energy efficiency. And so in British Columbia now, we have one way of measuring energy efficiency, regardless of which program builders may be using. In terms of what's regulated on the ground, local governments can only, building officials can only regulate what's written in the building code, and that's the Energy Step Code now. For industry, we heard loud and clear that they know we can build more energy efficient buildings. We've got great materials, we've got great builders, we've got all sorts of innovation happening, but there is not clear direction to date on, is it LEED energy efficiency? Is it Passive House energy efficiency? Is it Built Green or R2000? What training do builders need? Each of these programs come with a slightly different philosophy. And so there's a real desire to say, we can move forward, but we need a clear path around how we move forward. If we're going to do that in a cost-effective manner, that doesn't cut out one industry or another, and really provides everyone the clarity they need around how do we tool up, what capacity do we need to build over time, and that can't rely on bouncing between different programs in different communities. And arguably, I would say that should be the same between provincial jurisdictions. We can't rely on one program in one jurisdiction and a totally different program in another, particularly for suppliers and manufacturers who are trying to serve the entire country. And so the approach we've taken with the Energy Step Code, while trying to improve consistency, also has to fundamentally address, and here we've got a picture of British Columbia's 18-story tallwood building, Brock Commons at the University of British Columbia. Really this inherent desire, certainly in British Columbia, and I would argue across the country, to continue to make innovative buildings that are custom buildings. The market wants unique features in each building, and so we have no doubt the trend is that buildings are becoming more complex. We can't stop that. We have to work within that. And that prescriptive code requirements, and here I've pulled out the requirements for houses and small buildings, at least as they relate to windows and doors. The prescriptive requirements work most of the time, but as buildings become more unique and complex, it can become real challenging to satisfy prescriptive requirements and then also ask industry to innovate. And so what we've done is really try and take an approach that has as few barriers as possible. And what you'll see in subsequent slides is remove prescriptive requirements entirely under the Energy Step Code and say, how can we achieve the results that we're after? As we did with a tallwood building here, technically that didn't satisfy the code of the day, but we said, how can we maintain the level of safety that we're after? Define that in a performance-based way, and then allow the experts in the industry to find a path there without the building code telling them exactly all the materials and processes they have to use, just doing a really good job of defining the outcome we want and then holding everyone accountable for actually achieving that outcome in a way that makes sense for them. And that may mean something different than the prescriptive requirements we've got in the code. That was a big takeaway we had in British Columbia, and one that I think is worth considering as we have a national discussion here, whether we need to rely on a checklist-based code that tells people what to purchase and assume that achieves the outcomes that we're after, or whether we need to have a code that defines products less and just defines the outcomes that we're looking for as a system. In British Columbia, we've also obviously chosen one path over another, but that's an open debate discussion to have, I think, nationally. And I'd be interested when we get into the question period here about your thoughts on that. Now, ultimately, it's really worth noting before we get into the details, the Energy Step Code is not the province, not the product of the province alone. While we did lead the process, the Energy Step Code is the result of a consensus building approach where we brought together stakeholders who represented a range of different perspectives. We had green building advocates, we had affordable housing advocates, we had a range of different industry groups and experts all at the table, and we worked for 2 years until everyone nodded their head and agreed that what we proposed under the Energy Step Code can work, and detailed the plan around how to make that work in terms of implementation. I think that'll be important as well in a national process. It's not just creating a technical standard, but creating a really comprehensive plan around how we're going to implement any new changes in the way that we build buildings, because that's the biggest challenge that we're tackling right now. And that requires collaboration with everyone. And that means getting everyone to the table early to make sure that each industry can see their own success path in this roadmap towards 2030. But that requires having a really open discussion and getting everyone's ideas on the table and finding that consensus, not coming up with a solution beforehand and trying to impose it. So thankfully, I'm pretty pleased with the collaborative approach we took, but worth noting that I'm here representing a process that really was built on the work of a huge range of volunteers who contributed to this process. And so I'll jump into the technical details now, but ultimately what we're going to talk about now is BC's answer to how do we get to net zero energy ready. In British Columbia, we're shooting by 2032. We tend to adopt the National Building Code roughly 2 years after its national publication. So we're talking the same language, we're shooting for roughly the same timelines. And what we've got here in these steps and metrics is how British Columbia plans right now, at least, to move towards this path. I should note, as a policy in our office, we are strongly committed to harmonization with the National Building Code. And as soon as a national step code equivalent is available, they're planning around 2020. I'm involved in those discussions. We would look very closely at adopting that or modifying BC step code to be in line with a national step code approach, or whatever they may call it. So our roadmap to 2032, I should note, if you see different presentations for different building types, when you work towards consensus with a broad stakeholder group, you often don't get the clean communication consistency you're after. And so as a result, what we've got here for houses and small buildings in British Columbia is a 5-step roadmap towards 2032. And it's worth noting that's built off of the programs that already exist in the market. The number of steps we have is not the number of changes we have in the building code, because we really only have 2 more additions of the code before we get to 2032. We were trying to reflect levels of performance that already exist in the market in a voluntary way. And so we've got 5 steps for homes. When you get into large Part 3 buildings greater than 4 stories, we only have 4 steps. The end goal is still the same. It's just the logical increments of what builders are already doing between base building code today, you see at the bottom of the screen, all the way towards our long-term goal of net zero energy ready, ideally by 2032. For non-residential buildings in Part 3 as well, I should note we've only got 3 steps. Again, the number of steps is less relevant. It's the fact that they're all providing that roadmap from where we are today to net zero energy ready by 2032. And I think we're likely to see some similar tiered or stepped approach in a national building code. I should also note, actually, before I move on, the third-party programs shown on the screen here today are not can't be used exclusively to comply with the step code. We haven't referenced any of these programs except for Passive House as an alternate compliance path to the step code. They roughly equate to what we do in the step code, but as mentioned earlier, we've redefined energy efficiency in the step code, and it's slightly different from any of the programs, including the EnerGuide rating system that exists. So builders who build and satisfy Energy Star or Built Green requirements haven't necessarily achieved what we're after in the step code. They're usually 80 or 90% of the way there, but it's important to note that the regulation is slightly different from many of these third-party programs. So the big shift that we're seeing in the energy step code in British Columbia, the big shift that we think is necessary to get to net zero energy ready is that we need to move towards a performance-based system. We started our discussions in British Columbia around the end goal and talked with stakeholders around what does it mean to build net zero energy ready? How are builders doing it today? And what we heard loud and clear is that the only people building net zero energy ready buildings today, regardless of how you define that, are doing it with energy modeling and air tightness testing. It's not about a prescriptive checklist of materials that you purchase and assume you achieve high degrees of performance. If we're going to get to net zero energy ready, the highest level of energy efficiency that builders are building to today, that really has to rely on energy modeling and air tightness testing. And if we do that, we don't need prescriptive requirements, because what we're doing is setting clear goals in terms of performance outcomes that we're after, requiring an energy model to detail how the building got there in their own custom way, and then holding people accountable through air tightness testing and other inspection measures that we're talking about. Now, to require that and still leave room for innovation, we can remove a lot of the barriers in the prescriptive requirements of the code. We heard loud and clear, there are no programs on the market today that are prescriptive based and get us towards our end goal. And so in British Columbia, we decided that these are the skills, energy modeling and air tightness testing, that builders need to become familiar with, that the whole system needs to become familiar with if we're going to be able to move towards net zero energy ready. And it doesn't make sense to move people along the path in a prescriptive way if we know that by 2032, we can't have a prescriptive pathway to net zero energy ready. I think that's still an open debate, but this is where we've, I would say, deviated from traditional code writing, but we believe that this is actually the only successful pathway to get towards the end goal in British Columbia and nationally. And this is, I think, a really important discussion to have around this strategy and how we get there. So the big advantage here, we've got an illustration from a guide we have on the prescriptive requirements in the building code today, and we've got specific requirements for doors, windows, skylights, insulation, depending on where it is in the building. All of the details of the building have their own specific individual prescriptive requirements. And so long as the builder has satisfied all of these, they're code compliant. But what we found is that really depends on a whole bunch of factors in the home and may not make sense in all situations. There are some designs where builders may want to have maybe more efficient windows and ease off on some insulation requirements, or have some windows that are perhaps less efficient on a particular building face, and they want to be able to trade that off in a very flexible way. This is how a performance-based approach really allows that flexibility, removes all of these prescriptive requirements individually, and sets one set of expectations for the entire building envelope, and then just requires a builder to account for all of those elements and find out what the end result is. But it's up to them to choose how they balance that all out. It's already a performance pathway in the code today, but for the Energy Step Code, performance-based energy modeling is the only way you can comply with the Energy Step Code. But what that does do is really relieve a lot of challenges we've had with the prescriptive code. I spent 2 years as a energy code coach in British Columbia, dealing with builders and building officials trying to enforce the current requirements in the National Building Code, Section 936. And there are a lot of details that, when you write it out prescriptively, again, can really cause some issues and may be impossible for some projects. And that we heard from builders that a lot of these requirements they know that they don't achieve the energy efficiency gains relative to the amount of work that they require. Telling people that you can't have pot lights in an insulated ceiling assembly doesn't make sense, when a builder can say, well, I can find a way to do that and still achieve the overall goals we're after. But pot lights aren't airtight, and so making them part of the air barrier in a prescriptive code technically can't be approved. In a performance-based system, we can say, well, if you're assuming some air leakage through those pot lights, just make sure the home is airtight through a test. And then the individual components are less important, because what we're after is system-based outcomes. And that's the big shift in the Energy Step Code, is removing all these barriers and headaches in a prescriptive code and getting really clear and accountable, but that's a shift, really accountable on the performance outcomes of the home as a system. The result is that we have taken 120 pages of code content in Section 936, detailing all the prescriptive requirements for air barrier details, doors and windows and insulation requirements, your domestic hot water requirements, all of these specific prescriptive requirements, and reduced it down to a single table where we've told everyone you have to do energy modeling. Here I've got step 3 identified. And so a step 3 building just means do an energy model, conduct a blower door test. And for steps 2 through 5, we have specific outcomes that builders have to achieve, or they haven't satisfied the code in terms of airtightness that has to be demonstrated using a blower door test. And then we have 2 measures that I'm going to talk about here. One is in green here, there's either you can use the EnerGuide rating system and be 20% better than the code, or just calculate, if you don't want to use the EnerGuide rating system, do an energy model and achieve what we call here MUI, mechanical energy use intensity. And that's really taking a look at the mechanical systems inside the home. How efficient is the heating, ventilation, and hot water systems inside the home, and achieve the performance outcome we're after. They can choose any components they want to get there, but they have to achieve the performance outcome that we're after. This is pretty similar to the way we've measured energy efficiency in North America for a long time. The big shift that is more in line with maybe the R2000 program, and certainly the way that the Passive House program takes a look at energy efficiency, is shown in the orange bars on the right of the screen there. Here we've got 2 options, thermal energy demand intensity or peak thermal load. The specific terms are less important, but what they really do is measure the performance of the building envelope. How many good free gains are we getting through well-placed windows at the right time of year in terms of free heating? And how much energy are we losing through the insulation in the walls, the wall assemblies, and the thermal bridging we have? And most importantly, we found through air leakage. So really, the metrics that we've got there in orange are your options to comply with the Energy Step Code, really taking a look at how effective is your building envelope. What we realized is we have to separate that out from mechanical equipment, because when you bundle these 2 together, as we have traditionally in North America, on paper, it's really easy to over-rely on complex mechanical equipment that in practice aren't efficient for the building operator. And so by separating out the building envelope and setting some really high expectations for that building envelope, we say, you need to start with a really great shell and then focus on efficient equipment inside the building. But by doing a great job on the building shell, we can actually reduce the complexity and size and capacity of those heating and ventilation systems. We still need good ventilation and effective heating, but they can be much simpler because we're not losing as much energy, so we're not having to make it up through complex mechanical equipment that are trying to make up for a poorly installed air barrier or a poorly insulated building. But these performance outcomes really do require every component in the building envelope to have known, measured, tested, very specific performance outcomes. For doors and windows, a building designer is going to have a really difficult time knowing whether they're designing a code-compliant home if they don't know the U value for every single window at the design stage. That can't be done afterwards or on site. They would need to know very early on because their code compliance path depends on that level of detail at the design phase. And that's a bit of a shift from perhaps what we have in the market today in some cases. So really worth being aware of. This shift in terms of the way we measure energy efficiency, the big change is this shift towards the building envelope. So as mentioned, I won't go into too much detail here, but happy to share these slides afterwards through Anne. Is that when we're measuring the building envelope, again, we're just taking a look at traditional things here, nothing groundbreaking. What's new is that we separate this out from any of the equipment inside the building and taking a look at free gains at the right time of year and traditionally how we lose energy through the building envelope through insulation and air barrier details. And that's known as thermal energy demand intensity, TEDI, or peak thermal load. The only difference between these two is peak thermal load takes a look at the highest peak at the most energy intensive day of the year, whereas thermal energy demand takes a look at that annualized over the year and says, let's make sure your average per square meter of energy use in that building is as low as possible. Whereas peak thermal load takes a look at the highest intensity day of the year, and there are different situations where those two metrics might be useful to use. Then the other measurements that we do have, we don't want to totally ignore equipment inside the home. We do look at that, but we've separated that out. And so the ventilation, heating, and hot water for houses and small buildings, and for large buildings, Part 3 buildings, we're continuing as we do under the National Energy Code for buildings to take a look at all energy used on site. Is either called total energy use intensity for Part 3 buildings, so that's everything on the site. That's our traditional EUI in North America. And then for homes, mechanical energy use intensity. The only difference is just in homes, we scale it down to the equipment that really gets focused on. We're not taking a look at plug or lighting loads in houses and small buildings. And then the other option, of course, that we've written into our code is that builders can use the EnerGuide rating system so long as they actually submit their files to Natural Resources Canada to comply with the Energy Step Code. That's not present today in the National Building Code, but I think would be an important thing to consider nationally. And then last, but most important, is that we're not just going to assume a building is energy efficient and put it into an energy model. We're actually going to test it. We're going to do blower door testing on every single building in the Energy Step Code. We think that's certainly necessary in the early years of rolling out this kind of program. We can't just assume energy models are accountable. We know we have problems, certainly in the Vancouver and Victoria area, around air leakage in homes. We need to control that, and the way to control that is to set some targets and require builders to do some testing and be accountable for those outcomes in the code. And so for homes and large buildings, we're going to be requiring post-construction blower door tests. And that's to measure the air leakage to the building. And that's going to impact every component and how it's installed in the building. Less of an issue in large buildings where there's a lot of detail paid to installation of envelope components. More of an issue perhaps where we've got different trades who may or may not be talking to each other well in terms of installation details for houses and small buildings. We'll really want to be managing that air barrier detail well, because now it's going to be tested and accountable, and everyone on site who touches that building envelope will be part of that accountability system. So that's our shift in terms of energy efficiency, performance-based, looking at mechanical systems separate from the building envelope. And then what's worth trying out here, we've done some research, and I just want to draw out a couple findings we have around what this focus on the building envelope means for building design, building construction, and what it means to be compliant. A focus on the building envelope is not brand new, it's not revolutionary. It does exist to some degree, bundled in with everything else in the prescriptive code today. And so this really means reducing thermal bridging, which admittedly we're doing a reasonably good job of in codes today. But the new piece, when you get to a performance-based system and have the kind of metrics we've got in the Energy Step Code, is that we can actually incorporate not just the materials that are in that building, but non-material elements like the building form and shape and how efficient that is. How much thermal bridging opportunity are we creating by having bump outs on a building as opposed to a smooth building design? That's really new, but what we're seeing as we get to the highest levels of energy performance, that's going to become really important. Also, what we're seeing, if you take a look at folks who are looking at the highest levels of energy efficiency in the Passive House program or others, they're taking a look at even window placement in the wall as having an enormous contribution to thermal bridging. That's not a different product. That's just a design decision about whether you've got a large sill inside or outside the window can have an enormous impact on how effective the wall assembly is, just by placing that door or window in line or not in line with the insulation plane. These are the kinds of things we can start measuring when we have a performance-based system that are nearly impossible to capture in any kind of prescriptive approach. And then last, as I've mentioned, that focus on air tightness, this is really about getting towards accountability and quality assurance really on site, making sure that everyone's doing the job that technically the code always required them to do to make a complete air barrier that limits air leakage. One thing that's worth noting as we went through the energy step code, when you move to a performance-based approach and we remove the minimum prescriptive requirements on elements like doors, windows, and heating equipment and just ask people to achieve ultimate performance outcomes, it's been a bit of an eye-opener for building officials because they can't actually require builders to follow those prescriptive minimums anymore. And for some designs, it may make sense to have a slightly less efficient window in a particular situation and maybe save money there and invest in other windows in the home or make other trade-offs. And a performance-based approach does allow that. And we really wanted to make sure that building officials and others were aware of that because there's some real opportunities to maybe rebalance how we design and construct homes to minimize the cost impact and maximize the energy efficiency. And in some of the research that we've done, we've got it's called the Metrics Research Report. This is our costing research. We identified some key elements that when we were searching for the lowest cost ways of satisfying the energy step code, there were some key components where the energy model suggested we may want to dip slightly below what the minimum code expectations are in different climate zones depending on the building type. Not in all situations. Generally, we are going to have to improve all components in the building. But as we're moving towards these incremental steps moving forward, a performance-based system resets some of our expectations, and we need to be prepared for that. We need to take a look at the building as a whole, as a system, and focus less on the individual components. We need to know how they all perform, but there isn't necessarily a minimum expectation on each component. It's about how they all get put together in the complex system that is a building or a home. The other takeaway we had from some of the research that we've done is that the shape of the building, here we've got 3 building shapes, they all have the same floor area. And in a prescriptive code, you could build them all, they'd all be code compliant and treated exactly the same. And we would assume they have the same energy efficiency because they have the same materials, they've all satisfied the prescriptive requirements, and have the exact same floor area. What doesn't get captured in a prescriptive code, but does in a performance-based code, is how much contact is there between interior and exterior. And that's really managed by how complex your building shape is. And here you can see we've got a big U shape, lots of contact between the exterior and the interior floor area, or a really complex architectural sort of Rubik's Cube going on there in the middle. And then a more simple cube-like form, maybe a little brutalist in its shape. Hopefully we get some windows on there to brighten things up. But these 3 shapes, what we found, have dramatically different outcomes in terms of energy efficiency, just based on these design decisions that we make, not new materials. The exact same materials in the building achieve very different outcomes in terms of energy efficiency. And that's where we found this approach in the energy step code measures these differences. And from the simplest to the most complex shape that we were showing there previously, that's enough to move the same building with the same components. So the same costs other than labor for the complexity of those shapes. That same building with the same components is enough to, by just simplifying the shape at the conceptual design phase, move a building up 2 steps in the energy step code. This is for large buildings, but this was really an eye-opener for us and really revealed the importance of moving beyond just focusing on requirements for individual components and really taking a look at the home as a system, including its form factor, including taking a look at how we designed buildings and finding a way of driving change there, because that is the lowest cost way of improving the energy efficiency of buildings. Now, a cube certainly creates an architectural challenge in terms of making that beautiful and interesting, but I believe the architects of Canada are up to the challenge. But what we need to reveal now is that if we're going to hold project teams accountable for energy efficiency in buildings. That means accounting for every element, not just the components they purchase, but the design decisions that they make. And a performance-based approach allows us to start getting at some of that and encouraging that change. And then allowing builders to maybe back off some of the investments in more expensive, complex mechanical or envelope components. And then last is air tightness testing. We've talked about that already. That was the other one in our research that came away, certainly in our climate zone, in climate zone 4 and 5, as really low cost option that's really about quality assurance, that if you can improve your air tightness, you can make dramatic gains in by 2 or even 3 steps in some cases for the same building, just by improving the air tightness performance. That's about builders who just need to focus on doing a great job in the building envelope, many of whom are doing that today. And unless we do testing, we don't have any way for consumers to know the difference between a builder who's doing a great job on a building envelope and all the envelope component installs, and one who needs some improvement. And they don't know that until we do some testing and have some results for people to look at. So that was a really important takeaway for us in the building envelope focus in the Energy Step Code. The last piece I'll mention that's really worth being aware as we move towards a performance-based approach and understanding the complexity of a home as a system is that climate, here I've got the climate tables for City of Victoria. You can see we've changed from being in climate zone 5 to climate zone 4 just in 2 code cycles, and we expect that trend to continue. We can see that the climate is warming, and what that's going to mean is that we need to focus not only on heating, we need a really complex understanding of building performance, because we're very quickly in some parts of Canada moving to a shift where we may become a cooling dominated climate, particularly in the lower mainland in British Columbia, and we really need to think about how all the building components we have contribute today towards minimizing heating demand, and in the future minimizing cooling demand as the climate changes. And we really can't do that again unless we have energy modeling and some really complex understandings of these buildings, because the climate is changing and we need to be prepared for that. And we believe this approach sets everyone up with the information they need to make decisions for that. We've got about 3 minutes left. I'll just touch base very briefly on how the Energy Step Code is being implemented in British Columbia. As of December, local governments have started to consult on implementing the Energy Step Code and implement it. We provided some best practice guidelines for how local governments can incentivize or require the Energy Step Code, and some guidelines we've got for them, as well as some clear expectations on minimum timelines between telling builders you're thinking about implementing the Step Code and actually requiring them to do it on site. And we're happy to say that 100% of local governments who are consulting on Step Code today have been following these guidelines. What this really showed us as well in a national context is, as we make these changes, we need to think about how we can incentivize leaders to take on some leadership, try some improved energy efficiency, and then share that learning. And we're seeing local governments do that as well. We've got 25 local governments today in British Columbia consulting or who have adopted the Energy Step Code, all focusing on the lower steps. And what we're seeing is some good consistency between these local governments, but also a number of local governments around them who maybe don't have capacity or political interest for one reason or another to move forward on energy efficiency, but they're going to be able to learn from that. And I think in the national context, we need to think about how we can learn from those who are leading and make sure that as we move the entire market forward in a much broader way, that we learn from any lessons that industry leaders have learned. And so if you're looking to know what the future is, I would suggest in British Columbia, talk to builders in these communities, what they're asking for, what's suddenly important to them as they make this shift towards high performance buildings. That's where we're likely going to see our peak at what does 2030 look like in terms of home construction. The other change, I won't go into too much detail, but is really important to note is that as we shift towards high performance buildings, and particularly a performance-based system, that changes what it means to do inspections and code compliance. And we're working with Natural Resources Canada and building officials in British Columbia to really unpack that and provide building officials with a standardized way of inspecting for code compliance, when the building code will no longer provide them with a checklist of all the component expectations on the building. And so we're creating standardized reports, but this is really, everyone needs to work collaboratively to understand what does code compliance look like in the future. And that means connecting a lot more dots and information and having everyone be accountable for their own products and components as we go forward. Last, and we could go on for hours about this, but I would keen to dive into questions from you, is just some brief findings we have from our costing research that we've done. We have the full 100-page study available on our website, gov.bc.ca/building codes, or if you go to energystepcode.ca. But what we did in this study is take a look and say, we've got our assumptions on how energy efficient we want to make buildings under the Energy Step Code. Let's take a focus, and this was led by BC Housing, on affordable housing archetypes and find out what does this cost in each climate zone for each of these different building types to achieve each level of the Energy Step Code, with a real focus on what is the most cost-effective way to reach each of the steps. And we found some really interesting findings when we ran hundreds of thousands of energy models and then selected for the most cost-effective options that achieve the best results at the lowest incremental capital cost. There's been some debate in the market about whether the costs are accurate or not relative to what's happening on construction sites. And separate from that debate, I think what we have revealed is at least elements from that study that really have demonstrated what gets the best bang for your buck. Whether you agree in exactly what that dollar cost is separate from whether it actually has a significant impact. And what we did here is we've got our prescriptive home in climate zone 4. And so we've got all the prescriptive requirements met there. And to take that building to step 3, without going through all the details, I've highlighted in green here, we only need to improve a few key elements here. A little bit of extra insulation. We haven't changed anything in the attic. The doors and windows remain the same at a U value of 1.8. And then some slight improvements in ventilation and domestic hot water, and improvement in air tightness. We've got multiple examples of this where here's another home in climate zone 5. Again, we have an opportunity here to even back off of some of the prescriptive requirements in orange and then go beyond the prescriptive requirements in green and achieve 20% better than the code under the Energy Step Code, with really here no cost increment, because we're able to back off of some elements and reinvest in others, focused most on our energy outcomes as opposed to the prescriptive requirements in the code. And that was a really revealing finding for us, that we don't need to change everything in the building. We need to identify the components that have the most impact on energy efficiency and focus on those. Of course, the other findings that we had from that research and that I've talked about in the presentation today is that building orientation and shape does have a significant impact on energy efficiency. That those simple shapes are more cost effective to build and more energy efficient. And that the most cost effective time to invest is at conceptual design. But for manufacturers and suppliers, it's really worth noting that the need for detailed, accurate information at the conceptual design stage is really increasing, and we need to move to a point where suppliers are accountable for their products and are providing all the energy efficiency related information prior to the products being built. We need to know ahead of time so that can be factored into designs, or else it's going to be really challenging for builders and designers to know what their own path towards a particular step looks like. And I think that's likely to be a trend that we see nationally as well. With that, we've got 17 minutes for questions. Happy to take questions.
Thank you, Zachary. As Zachary mentioned, we are now open for the Q&A portion of the webinar. If you have a question for Zachary, you can send it through the question box on the GoToWebinar dashboard, or if you'd like to ask your question verbally, you can use the raise your hand feature that's also located on the dashboard. If you decide to ask your question verbally, just be mindful of background noise when I unmute your line to ask your question live to Zachary. We have received a few questions, but I just wanted to take a quick moment just to remind everyone that the Fenestration Canada Spring Conference is in Calgary, Alberta this year, so close to your neck of the woods there, Zachary. Well, not quite, yeah, but closer than most of our members are. The event is from June 4th to the 6th, and if you haven't already registered, you can find the event details on the Fenestration Canada website. The website link is www.fenestrationcanada.ca, or you can contact us via email at info@fenestrationcanada.ca, or you can call us at 1-888-543-2516 for assistance. Zachary, first question. You state that we can use the TEDI or PTL or MEUI or reference has performance-based paths. BC Housing released a step code guide which states only TEDI can be used and TEUI, total energy use intensity. I assume TEUI is in LEUI of MEUI. Please advise. As well, as this is for Part 9 buildings, the BC Housing Guide, what is the case for Part 3 buildings? I hope I said that right. I apologize to if I didn't.
Yeah, I think I can actually answer the question without having to describe all of those acronyms. The BC Housing Guide, I think that's probably the design guide. That's actually focused on Part 3 buildings. And so for Part 3 buildings, we only have two metrics. You have to use total energy use and thermal energy demand intensity, TEDI and TUI, we call them. There's only those two options in Part 3 buildings. There's no other variables. For Part 9 houses, for the equipment and systems, you can either use percentage better than the code using the EnerGuide rating system or mechanical energy use intensity, either of those two, and one of the two of either thermal energy demand intensity or peak thermal load, PTL. I assure you that information is maybe a little clearer and easier to digest on if you go to energystepcode.ca, we've got a lot of information there that will help map out the difference that we have between Part 9 buildings where there's some more options because we've got more programs on the market, as opposed to large buildings where it's really been simplified down to two metrics that they shall use. I hope that answers the question.
Thank you, Zachary. And if you have any follow-up questions, feel free to type them into the question box. Next question. I am wondering if there is a link to what cities are participating in step codes that is live and updated regularly.
There is. I should check if it's on energystepcode.ca, which it should be, but we do keep a list that's always updated, at least certainly once a week, on our website. If you go to gov.bc.ca/building codes, or if you Google Energy Step Code, BC Energy Step Code, our branch website will show up as one of the top sites. If you can't find it, please email building.safety@gov.bc.ca and we can send you the longer link to the exact page where we have local government notifications. But we are tracking that and we're making that available for the purpose of making sure that industry is aware of who's implementing, what regions do we need to start preparing for some significant changes. I should note that what we are seeing as a general trend in British Columbia, particularly in the Lower Mainland and Vancouver Island, where implementation is quite strong by communities, is most are starting off at step 1, so not a real change in what we're building today, but most are looking by 2020 to go to 20% better than the code. That's a shift in how we construct, and that's a natural trend that we're seeing from local governments, and really worth being aware as an industry around what does that mean for your products and market if we see that shift towards 20% better than the code by 2020.
Thank you, Zachary. Next question. How will BC address the issue that energy use intensity penalizes smaller houses?
That's a great question, and that was a concern that was raised when we first implemented the step code. And what we committed to do was more research, which we did with our costing study to understand the question better. And I just got off a call yesterday morning where we were unpacking how we were going to resolve that. And it looks like we're going to make a change. Today, most local governments actually for very small homes, laneway homes or garden suites, are just, if they're requiring large homes to go to step 3, they're allowing these smaller homes to go to step 2. And we've advised local governments to do that in our best practices guide for them. Longer term, what we're looking to do is actually amend the regulation and effectively put a bit of an energy use allowance for smaller buildings to address the fact that it's just it's not fair effectively for very small buildings less than 1,200 square feet. And so the answer to that is really having some kind of extra allowance, either through a formula or something else, to allow for small buildings to make the same level of effort to get to step 3 as a larger building of 2,500 or 3,000 square feet. So it's a known issue and one that we're working on, but was a little more complex to unpack.
Thank you, Zachary. I believe that was our last question for today. If you have any follow-up questions after the webinar, you can send it through to the link that Zachary has on his screen, or you can send them to us, Fenestration Canada, directly, and we'll forward them off to Zachary and his team. Our email is info@fenestrationcanada.ca. Unless you have any final thoughts, Zachary, we'll just end it for today.
No, I'd like to thank everyone. Actually, what I will encourage everyone to do is engage with the national code development process on this topic. The work is underway through Codes Canada. I would encourage you to reach out to Codes Canada to get engaged and be part of the discussion. What we've done in British Columbia, we're bringing to the table for information in that national discussion, but we need to find a roadmap towards net zero energy ready by 2030 that works. And over the next 12 months is when we're looking to answer that question. And so we're only going to be successful if we have all views at the table, not just those who are particularly interested in that early on. So I would encourage everyone, whether you like this trend or not, to be engaged in the discussion to make sure that we have the most well-informed plan nationally. Yeah.
Great. Zachary, on behalf of everyone on the line, thank you so much for taking the time today to do this webinar.
Excellent. Thanks very much, everyone. Thanks, Anne.
And everyone, have a great day.